This is a video for day 1 of our second part of Unit 3, Topic 3, Pre-Calculus, and we're going to learn some new identities today. You can see by the title here, it is the sum and difference of angles identities. To start, let's say that x is 90 and y is 180. So let's add those together. 180 plus 90 is 270. So thinking back to quarter 2, what is the value of sine of 270? All the way down here at 270, sine is the y coordinate over the r, so that's a value of -1. Let's do this separately. Now let's do sine of 90 plus sine of 180. So using the 90 degrees up here, sine would be 1 over 1. 180 would be 0. 1 plus 0 is 1. So are these the same? Is sine of x plus y, -1, the same as sine of x plus sine of y? No, they're not. We need new special identities. If you look on the back of your new calendar, we have a new set of identities that we're going to focus on. Right here is sine alpha plus beta or alpha minus beta, cosine, and then underneath the other two, tangent. So let's talk about what these symbols mean, because this is six identities written in 3. So on every assessment this semester, you're going to get the formula sheet. These 3 condensed identities are on your formula sheet, but let's write them out just so we can get used to the symbols. So with the alpha plus or minus beta, it's a matching. The top symbol here of adding, so when I add the 2 angles, I'm going to expand to this identity and use adding as well. If I have sine of 2 angles that are subtracted, that's the bottom symbol, we're going to use the bottom symbol here. So sine, S-I-N, the signs, positive, negative, stay the same. The plus goes with the plus, the minus goes with the minus. In cosine, with the plus on the top of this condensed symbol, it goes with a minus when it's expanded. And the minus here goes with the plus here. So this with cosine, your signs change. Positive goes to negative, negative goes to positive. And then tangent, if there's adding between the angles, in the numerator there's adding, but in the denominator there's subtracting. If we subtract angles, then we've got subtracting and then adding. So this is 6 different formulas condensed, written as 3 with that plus or minus notation. So let's write sine expanded out just so we can match up what the symbols are. So sine of alpha plus beta, it's like an A and a B in Greek, is going to be sine alpha cosine beta. This plus goes with the top here, that's a plus. Cosine alpha sine beta. Now if we take the bottom part with the minus, we're going to expand it to sine alpha cosine beta. But then with that bottom symbol, minus, and then the rest of the terms there. Now let's do cosine. If it's alpha plus beta, that top symbol, it's going to expand to cosine alpha cosine beta. And then minus sine alpha sine beta. And now taking the bottom, subtraction between the A and B, oops, will be a plus on the right side. Okay, and tangent, so tangent expands to a fraction. So let's do tangent of alpha plus beta. That's going to be plus on the left. On the numerator is plus in between. And then the denominator will have the minus. And then one more. So a minus between A and B goes with a minus in the numerator. And a plus in the denominator. You don't have to memorize any of these identities. All 6 are given to you on your formula sheet. What you do have to know how to do is read the plus or minus notation and how to match that up on the right-hand side. All right, so let's go back up to the warm-up here. Express the angle as a sum or difference of special angles. So our special angles are any quadrantal. That was 0, 90, 180, 270, 360. Or from our special triangles, yes, those are coming back, 30, 60, 45. And then these reference angles in any of the quadrants. So if we go into quadrant 2 over here, for example, 180 minus 30, 180 minus 60, 180 minus 45. In the third quadrant, it was 180 plus the angle. And then the fourth quadrant was 360 minus the angle. And actually, now we're going to work in degrees. It's a little bit easier to do these problems in degrees. We're much more familiar with adding and subtracting in these nice integer values without having to deal with the fractions of a radian. Okay, so from all these choices, how can we add or subtract to 15? We could do 60 minus 45. We could do 45 minus 30. How about adding or subtracting to 75? Did you think of 30 plus 45? And now with radians, it's easier to change to degrees. So anytime I see a pi, I'm going to replace that with its equivalent 180 degrees. And then we've got our denominator, so let's reduce this. 18 and 12 both divide by 6. So that gives me 30 degrees divided by 2, which is 15 degrees. Oh, we already did that. Here's our choices. So if you turn the page, let's talk about how we use these expressions, these identities. Number 1 says, find the exact value. So 105 degrees, that's in quadrant 2, but the reference angle is not one of our special 30, 60, 90. So we're not going to use just a straight one special triangle. Instead, we can use our sum and difference formulas. So I want you to pause the video here, pick for a moment 2 angles that can add or subtract to 105. There's many choices. I'm going to go with 60 and 45. If you pick something else, that's fine. If you want to get the same exact process with me for the first one, change your choices to 60 and 45. So using my identities here, I've got a cosine with 2 angles, and we're adding. So that means when I expand it out, I'm going to use subtraction. So cosine of 60 plus 45 is equivalent to cosine of 60, that's the A, cosine of 45, minus sine of 60, sine of 45. And now we're going to find the exact value of all four parts from our special triangles. Let's start with the 60. With a reference angle of 60, we have root 3 across, 1 next to, and 2 is the radius. So cosine 60 from this picture is x over r. That's 1/2. Sine of 60 is y over r, root 3 over 2. Bring down the multiplication, the subtraction. So now let's do the 45. This was one form of the 45. Don't write this yet, just watch a second. If we do this, my denominators, that's not nice. 2 times root 2, I can't simplify that at all. So for these problems, anytime we have 1 over root 2, we're going to use its equivalent form without the square root in the denominator, which is root 2 over 2. Now we can condense. When you multiply fractions, we multiply numerators, multiply denominators. These cannot simplify because of the square root. You can't change this 2 under the radical. Root 3 times root 2 is root 6. 2 times 2 is 4. We have a common denominator, so our final exact value is root 2 minus root 6, all divided by 4. So cosine 105, this is the exact value. All right, let's try the next one. Sine of 255. Anytime these degrees end in 5, I know 45, because of our special angles, is the only choice as one of the angles. So I'm going to pick 45, and then let's do some little scrap work over here. Oops, not that angle. 255. And I'm left with 210. 210 is a great angle to use because that's in quadrant 3. How much past 180 is that? So this 210 will give me a quadrant 3 reference angle of 30 degrees. So that's from our special triangles, and we'll be able to use it. So with the sine, I've got adding. So I'm going to use adding on this side. So let's match it up. This is the alpha, this is the beta. So I took this left-hand side, sine 45, cosine 210, stuck with my adding, cosine 45, sine 210. We already had those values for sine and cosine of 45 from our first problem. And now this picture is too small. I'm going to draw it again over here. 210 is in quadrant 3, 30-degree reference angle, down 1, left root 3, radius is always positive. So cosine is x over r. Sine is y over r. And let's multiply numerators, denominators. You can write this -1 root 2 as just minus root 2. So our final combined fraction is negative root 6 minus root 2, all divided by 4. Anytime we're given radians, we're going to degrees. So we got 5 times 180 over 12. I remember the 180 over 12 reduced earlier. Those both divide by 6. So now I have 5 times 30, which is 150 divided by 2. So that is 75. So this problem is really saying find the sine of 75 degrees. Uh-oh, where'd my identities go? So what two angles will add or subtract to 75? I'm going to pick 30 plus 45. So with sine, here's my adding, going to adding on this side. Here's alpha, here's beta. Got my 30-degree reference triangle, y over r. I've got this one in my memory, x over r. 45's in my memory. If not, draw it out. Draw it out. Got to change your 1 over root 2. We don't want that radical in the denominator. Multiply numerators. Multiply denominators. Multiply numerators. Multiply denominators. It's adding in between. We've got a common denominator. And there's our final value. So all of these problems are expanding. We had a very small expression, sine of 75, and we expanded it out to the right-hand side of the identity. When we turn the page, we're going to go the opposite way. Now we're going to simplify each identity. Move this a second. So I am going to analyze the structure of the expression. I see I've got cosine, cosine, plus sine, sine with the 80 and the 20. So looking over here, the cosine together comes from the cosine sum difference expression. So that's why I had this little screenshot underneath. See how that lines up like this? So to condense this long expression, we're going to match that to the cosine sum or difference with adding here. That's the bottom symbol. So we're going to condense with this bottom symbol. 80 is my alpha, 20 is my beta. So we've got cosine 80, 20, and we're going to subtract. So we simplified. Now evaluate if possible. Is 60 one of our special angles? It sure is. So cosine is 1/2 x over r. Ooh, finally a tangent. So in number 2, I see tangent, tangent, tangents everywhere. And 3 alpha, 2 betas. So with this tangent formula, in the numerator, we have subtraction. That's the bottom part of the plus or minus. So I'm going to use the bottom part here. The 3 alpha is in the first angle spot. The 2 beta is in the second angle spot. Nothing left else to do. That's as simple as it goes. I cannot simplify that anymore. Okay, you pause the video here and try number 3. What are you going to match that up to condense with? So I'm seeing cosine, cosine. That's another cosine doubled together. So it goes to cosine sum or difference. Subtraction in the middle. So the top part, so that goes to addition between these angles. And cosine of 65 degrees, we can't simplify, evaluate that anymore. 65 is not a special angle. Even if I had tried that back here, 35 is not a special angle, even though 30 is. So this problem's finished. Oh, another one in radians. Cosines together again. Plus in between goes with a minus in between our angles. When we subtract fractions, we need a common denominator, which we've got. So 7 minus 5 is 2 pi over 6. 2 and 6 reduce. They can divide by each other, so we get pi over 3. Hey, that's one of our special angles. If you're a degrees person, that's 60. If you're a radians person, put that pi over 3 here. Cosine x over r, we get 1/2. All right, 2 more and then we'll start our homework. Pause the video here for number 5 and decide, are we going to use the sine, sum and difference, cosine? It's not tangent. With sine and then cosine, now we're in the sine, sum or difference equation. Plus in my given equation is the top symbol here. So we're going to use the top symbol here. So that is sine 30 plus 40, which is sine of 70. And I cannot go any more simplified than that. That's not a special angle. So let's try number 6. Now, for number 6, pi over 3 and pi over 6, they're already my special angles. But let's simplify first, because then that will be less work to do to get our triangles. That goes sine, cosine, so that's here again. Minus is the bottom, so we're going to use the bottom. Here's the alpha and the beta. Oh, I need a common denominator. I'm going to multiply this by 2 to make it 6. So this is by 2. This is really 2 pi over 6 minus pi over 6, which is 1 pi over 6. And now we can go to our special 30-degree triangle. And sine is y over r. A common question is usually, hey, but Miss Weiss, where did this half of the equation go? It's not that it went anywhere. We're given this entire expression the long way. We're going to condense it to what it's equal to on the smaller, on the left-hand side. So it's not that any part of the equation's disappeared. It's not that it's just gone. It's that we're using our formulas to take the long expanded right-hand side and condense it to the short left-hand side. Your practice, if you look at your calendar, is page 4 to 6, but just these select problems, 1, 2, 6, 9, 23, and 29.